let me go back. So yesterday, when we finished talking about liquids, I was supposed to talk about solids. And I jumped right over them and went for phase changes. So I need to backtrack for a minute and talk about the two types of solids. This is very short. I should have done it completely spaced it. So the two types of solids, before I forget, and then we'll do my Plicker review. The first type is called a crystalline solid. And some of you might remember, probably nobody, but way back at the beginning of the semester when we talked about balanced equations and we talked about symbols in the equations and we talked about S, and we talked about L and G in balanced equations, I gave you a symbol that was CR that might be seen in a chemical equation. CR stands for a crystalline solid. Okay? A crystalline solid is just a solid with a fixed geometric pattern and it melts at a definite melting point. Hey, Devin. You told me you weren't here today. Yep, I did all that. I just skipped this like a big dodo.
Right.
Hmm?
But you got class in me.
Who?
You.
Who?
You.
I didn't say nothing.
No, she didn't come to your defense and say you were here. They just said you weren't here, so I marked you
I
absent.
didn't hear it because I want to be.
All right, so what would be some examples of some crystalline solids? All right, salt would be a great example. Okay, ice is another crystalline solid. All right, sugar is another crystalline solid. And these are actually three that I want you to know what their crystal shape is. They're the only three I'm going to make you know. And that's because they're so common that I think they're worth knowing in an honors class. All right, salt has a cubic shape. Ice is hexagonal. And sugar is also cubic. Now, if you remember back when we did bonding, when I talked about the crystal lattice, I told you there were only 7 types of crystals. These are 2 of them. Okay, cubic is one of them. Hexagonal is one of them. I'm not going to tell you what the other 5 are because you don't need to know them. All right. There's orthorhombic. There's rhombohedral. There's a couple other. I'd have to look them up because even I don't have all 7 of them memorized. But those are 2 of them. Now, ice. A lot of people know that ice is less dense than water, right? The reason that ice is less dense is because when the water freezes, it forms these nice little hexagons on the molecular level. Well, inside of these hexagons, air gets trapped inside the hexagons. And so, that's why ice expands and will crack your container. So if you, let's say you were going somewhere and you wanted your bottle to be cold and you wanted it to freeze so it melts throughout the day, the ice will expand and crack the side because air gets trapped inside. And that's also why water or ice is less dense and why it floats, because there's air inside of it. Okay? Now, the other type of solid you have to know is called amorphous. And I don't want you to call it that A word. It's pronounced A, more. PH is what sound in English? What's a PH sound? It's an F sound. So amorphous. All right, amorphous. This is a solid with a random arrangement. Okay? It's a solid with a random arrangement of particles. And it melts over a range of temperatures. Okay, so the difference between amorphous and crystalline. With a crystalline solid, once it reaches that temperature, it's going to melt all at once. If you have a small sample and you're able to put it in a machine, when it reaches that temperature, if it's a solid, it will liquefy all at once. Anything that's amorphous, if it's amorphous, it will get soft and sticky and gooey, and then eventually it will liquefy. So, can you think of anything that fits in that definition of it gets soft and sticky and gooey? What? Sure, plastic is amorphous. Can you think of anything else that's soft and sticky? Huh? Foam is probably going to be amorphous, yes. What else? Anything else? How about rubber? What else gets soft when you melt it? Ice cream comes from water. It's gonna be crystalline. What?
Lily said marshmallow.
Mm-mm. What? No. No. Huh? I want to say no to that one too.
A marshmallow. Gum.
But
Marshmallow.
marshmallow may fit in amorphous, yes. Marshmallow may fit there. But given a marshmallow has more sugar than anything else, I'm going to lean towards crystalline with that one too. Because the marshmallow is largely sugar. I was thinking wax, glass. Glass it's very soft.
Isn't it just sand?
Mm-hmm. Fiber optics. I feel like there's a big one I'm missing. Glass, rubber, plastic, wax. I don't think I have any written down though. Oh well, that's close enough for government work. All right, that's what I left out yesterday I meant to do. So where are my Plickers cards? All right, we don't have a lot of questions, but I wanted to do something to review since I didn't give you homework last night. And then we're going to talk about our graph and we're going to calculate some math problems. All right, let me throw these out so you can see the numbers a little better. Then I'll pull your numbers up so you can see.
You're not.
And I know I don't need 19 and 20 because Dylan and Juliana are not here.
They should have got me something. Wait, I'm through. Right, I'm through.
Yeah, I think so.
This water is so good. Can I have my water? What number was that?
What number am I on this one?
I'm going to get it.
Okay. I think I was 17 or 9.
It'll come up in a second.
I think I'm like, pull up there. I want you on this one.
Oh, I can get there. There we go.
Can I put my Gary in the fridge, please? I'll put my gator in your refrigerator.
You put my what? Your what in my
My
refrigerator?
gator in your refrigerator.
I need classes first. Chemistry. So y'all know what numbers you are.
Please.
Yes.
Yeah.
Yeah. There we go. There are your numbers.
Where's it at? Yeah. Is yours the little black one?
Yes.
Broke the gym door today, bro. I thought somebody stole my phone. But it turns out Coach had my phone. I thought Ulysses stole it, bro. I was really about to go fight.
All right. Everybody got their cards?
I walked all around the school.
All right. Based on yesterday.
Where's my
All
thingy?
right. You got to take your fingers off in front of the black or it will not scan. Okay? All right. Everybody ready?
No.
Yes.
Let's go away. All right, I'm missing Destiny back there. Just swap my card around like crazy.
Will these questions be on the quiz?
It's a possibility.
Can we take a picture of them?
Bryce, are you playing
We got a quiz.
Monday?
Monday.
All right, I've got everybody then. except Bryce. Good. All right, so that's not bad. One person got it wrong, and the person wasn't here yesterday, so it's not bad. All right, because heat is on the left, it is endothermic. All right. All right. The particles in a liquid have. All right, think about the pictures and what we talked about.
I'm going. I'm ready as well. You can go ahead and scan me.
Okay, hang on, everybody. And Nancy first, some people are still thinking.
Who got some food? Timmy got some food.
Did you have a note or anything, or were you just like?
Oh no, I could have got one from Coach, but I didn't. You want me to go? I can go get one though. Cut. He had I lost my phone. Well, I didn't lose it, but somebody had picked it up, I guess, and I couldn't find it. So
Hey, what you want?
Coach had it, so he gave it to me, but I could go get a note if you want me to. He said he'd give me one if you asked for it.
So who had your phone?
I don't know. I was looking for it. I thought one person had it, but I guess he did. And then we was tracking it down, and some girl told me Coach had it. So I don't know how it got to him. I know I set it on the bleacher. If nobody would have touched it and just left it there, we wouldn't have had a problem. But they want to touch my stuff. So yeah.
Uh-huh. Where'd you come from?
Home.
So you just got to school.
That's nice.
Upset.
All right, ready? Jennifer, you gotta move your hand.
No, I put the wrong
You can't flex the card.
I'll take it.
Oh, no.
You got one right?
I think I got yours. That's me. All right, what we got?
What you
I
choose?
don't have yours. Yours didn't read.
What you put?
All
Oh
right.
yeah, bro. I knew. I said, wait a minute.
All right. Whew, that was not good.
Bro, I just
7
put
right,
E.
or 6 right, 7 wrong. All right, 4 of us picked 3, or 4 of us picked A, 3 of us picked B, and 6 of us got the right answer.
C.
All right, the particles in a liquid, all right, have less energy than those in a gas. Which particles move faster, a liquid or a gas?
Yes.
The gas. The gas moves faster. So in A, the particles in a liquid have less energy than those in a solid. Does the liquid have less energy than a solid? No, the solid has less energy. The solids are locked into position. They have less energy, so that's wrong. The particles in a liquid have more energy than a gas. Does a liquid have more than a gas? No, the gas has more, so B's wrong. The particles in a liquid have less energy than a gas. Yes, that was right. All right, that one wasn't too hot, guys. Try the next one. The answer was C. All right, what type of matter can translate and rotate? Okay, what type of matter can rotate and translate?
Hold up.
What type of matter can rotate and translate? That's salt.
What's that?
Oh, Fe is iron. And then C is what? Copper?
Yeah. That is what.
C is copper, Fe is iron. And, I want to say that, but
You got an answer over there?
Okay, whatever. Hold on.
All right, I'm missing 2.
choose A, Jennifer. Choose A, Jennifer.
What you mean?
You got it wrong.
All right, who am I missing? Anybody? How about I need you? Okay. That's everybody. All right, so 10 of us got it right, 3 of us got it wrong. What do you look at to figure out if it'll rotate or translate? The states. AQ means it is a liquid. It can move. SSS means it's a solid. It can only do what? It can only vibrate. Very good. All right, next question. Which types of matter have motion? If y'all get this wrong and we don't get 100%, I'm going to be so pissed.
All right.
Yeah.
Is that right? I did it wrong on purpose. It's wrong on purpose.
You better not answer it wrong.
I was on my stomach hurt.
Good thing.
Wait a minute, don't.
We already got 2 people get it wrong.
What?
Tell
Yeah. I got it for the wrong one.
He was
Oh.
He wasn't here for the one.
It was C.
Yeah, but
You sure?
Yeah.
It's on time. Did you get mine?
Swear to God.
yeah, I think I did, Destiny. Yeah, I got you. All right, so 2 people got it wrong. 1 person was here and got it wrong.
Did I get it wrong?
What types of matter have motion? All types of matter have motion. Solids, liquids, and gases have motion.
Oh,
How many times you want me to say that?
Oh, this is
You at least weren't here.
Yeah.
Somebody else in this room was here and still got it wrong.
Oh, yeah. Oh, yeah.
Aren't you done? Okay. All right, which reaction is exothermic? Out of those, this is probably the hardest one out of the 9 I think I had up here today. Which of those is exothermic based on what we did yesterday? This is the part that will drive y'all cuckoo about yesterday's lesson.
I think it's, yeah, I think it's this one. Bro, I had to see that in middle school.
Your finger is on part of the black. There you go.
I told him that
I didn't sing it though. I ain't never go to the concerts.
she always did that, especially like the practice. She was
I was about to-
Destiny, fingers in the way.
right there.
Oh, wait, hold on. I just thought about it.
I really think it's
All right. So we got 9 right and 4 people got it wrong. Which one has to give off heat for it to happen?
B.
B, condensation. You have to heat it to evaporate. You have to heat it to melt, and you have to heat it to sublime. Condensation is the only one that has to give off heat for it to condense. All right, solids are not fluids because why? Why are solids not fluids? There should be an easy one.
Solids don't
Oh, so
You there?
if you wanna be my baby, it don't matter if you're black or white.
If you want to say, go hang out in this rack.
I'm gonna bleach my skin.
I don't care if you
I'm gonna
bleach
get
your
my
skin.
nose fixed.
Just shut up. Unless you want to say Ms. Rector. I'm missing Destiny,
Who's Miss Rector?
the chorus teacher. All right.
No, she
That's-
already does.
Finally, we got a question that everybody got right. All right, last question. Which is a property of a solid?
Oh,
Oh my God.
I hope not. On the marked one.
Oh, it's solid. Okay.
Jennifer.
His freeze name starts off.
Somebody go. Jennifer ain't go.
I don't know.
I got waiting on 3.
Oh, it's B. Is it B?
Waiting on 2. Because I've only got 11 scanned. Waiting on Jennifer and Tim. All right, so we got 2 people who got this wrong. Which one is a property of just a solid?
Me?
B. Solids melt. Liquids freeze.
What did I put?
You put it right. All right. If you will, put my cards back up there on my desk, preferably with a number up, because I'm going to use these again 3rd period. So just put them number up so that they can see the numbers too.
Miss Wall, it's a frisbee.
It's not a frisbee.
Number.
Stop slamming it.
All right. If you will, find your notes.
What you mama? I don't know what you mama.
Let's have a show day today.
We're not having a chill day. We've already had that conversation. There are no chill days in my world, like ever. There's no buy one. The only chance you got is I get hit by a bus.
Good job, boss. I'm gonna do this serious.
All right, just as a quick review before we practice. All right, tell me what A was yesterday.
Solid.
I ain't finished.
Guys, I've gone to hell.
No.
I ain't finished writing it.
B is solid. B is solid.
I'm still in hell. Somebody tell me what's happening at A on that graph correctly.
I don't know. I ain't finished
It's
writing
going
it.
up.
All right, at least somebody can tell me it's going up. All right, what is A?
I forgot.
Solid.
It is a solid state,
Oh, bullet point.
and it's doing what?
Heating.
It's being heated. Alright. What's happening at B?
It's melting.
It's melting, or it's doing what else? What's the opposite of melting?
Freezing.
It's freezing. Alright, what is C?
Liquid.
It's a liquid, and since it's going up, it's doing what?
Heating.
It's being heated. What's happening at D is in dog?
Evaporating.
It's evaporating, it's condensating, or it's boiling. Alright, and what's happening at E?
Gases.
It's a gas. Now, the graph I just handed you, please don't lose, because I'm trying to conserve paper. So on Monday, we'll talk about the graph that's on the backside. We will not get to the graph that's on the backside today. Now, on the front side, there's a graph that looks very much like the one that's on the board. I'm going to give you 5 minutes to answer those 10 or so questions.
Could you tell me what A was?
A is a solid. It is being heated. Okay?
Brian, I wish you would pass one back.
B is melting point.
Melting point and boiling.
Oh, no, what's the? D is bullet point, right?
D is boiling point, yes.
B, I thought it was liquid.
D is changing from a liquid into, or liquid into a gas. That would be boiling, evaporation, or condensation.
D, correct.
You know, could y'all get quieter food for next week?
Can we bring some cake?
Can you bring cake?
Yes.
Good God, no, that's messy.
What do we share?
It is like supremely messy.
What about some muffins?
I think I want to do something that's like in the.
Find me some answers, quickly.
Someone translate.
I don't know, I'm thinking. I'm gonna miss the 11. That's the game. I have
If you wanna be my baby, it doesn't matter if you
Okay,
like
I'm
what.
really up there.
If you don't shut up, you're gonna be singing to yourself in the hallway. Yes. Yes, it's reviewed from yesterday. Were you here yesterday? That's why you don't know what it looks like. There's my graph side of questions. There it is. In questions 1, 2, and 3, it's not a letter, it's a number.
Oh, 1, 2, 3?
Yes, 1, 2, and 3 are not letters, they're numbers.
5?
Oh, yeah.
Because it's asking for an actual point, it was a number. So Tevin
Where is bullet?
and Salma are here.
Oh, yeah, show them one.
That's like 20.
Yeah, you show them that, you know, really.
It's like 20.
Y'all are gonna have mark.
I like all of everybody.
Oh, sure. I was looking at
All right, anybody else have a question? Now that I've fixed the attendance.
Yes.
Yes, what's the question?
I don't have a question.
Hi, brother. Sit down, work.
You're gonna be 5, right?
Anybody else have a question? Anybody?
It's the Brisbane Wildcats.
No.
What
Yes.
What? I would do kinetic first. Kinetic's easier.
What's crystallization? Is that solid?
I need help with mine.
What? Is it good?
Environment, the exit.
Do 10 first. You do 10 first, it's easier to do 9.
I still forget it. Back to talking to
He
yourself.
doesn't know how to.
You're just, you're over there.
Where? Whatever.
You're looking over there. Just
Ira,
Not know how to.
do your practice.
I fell asleep.
No, you put.
Most people are down at the bottom, and you're still up there pointing, I did 1, 2, 3.
You put numbers in 1, 2, 3, not letters.
Oh, we're not supposed to put the letters?
You put numbers in 1, 2, 3.
Miss Law, you're always putting them out there.
Thank you. Only 1, 2, 3 numbers.
If y'all would listen like everybody else, I wouldn't always be putting you on blast. Listen.
Oh. The freezing point of the surface is 32 degrees.
No, it is not.
She got me dead.
What is the freezing point?
A freezing point is a number. So match up your letter with the number. So the letter you have, so the ball point, that's the number you had. Okay. So it would be what? You had D,
Oh, okay.
so match it up with the number. All right, let's look at some answers. Those of you who haven't gotten anywhere, I'm sorry. So if you look at question 1, it said, what was the freezing point of the substance? So freezing point would be 5. Those of you who wrote D, I told you, it was not a letter, it was a number. So 5 degrees Celsius. Now, if you only wrote 5, you would have lost points because, again, what do you have to put on a number? A unit. So in number 2, it says, what is the boiling point? Boiling point would be what? 15 degrees Celsius. Y'all didn't just write 15 again, right? Number 3, what is the melting point? That was a better answer this time. Number 4, ask what letter, so you can write a letter this time. What letter represents the warming of a solid? The warming of a liquid. And the warming of a gas or vapor. All right. Now, number 7, what letter represents the melting of a solid? B is fine. What letter represents the vaporization of a liquid? D. Now, several of you asked for help with 9 and 10. So when you get to 9 and 10, I told you to do 10 first. 10 was easier. So it says, where does kinetic energy change? What is kinetic energy again? Energy of motion. What affects the kinetic energy of a particle? Temperature. So where is temperature changing on the graph? Where is temperature changing on the graph? And? So in number 10, where is kinetic energy changing? A, C, and E. So in number 9, where is potential energy changing on the graph? Voila. Number 11, what letter represents condensation? D is in dog. And number 12, what letter represents crystallization?
I put D.
All right. Think back to those of you who said you made crystals, even those of you who did not. To make crystals, what do you start with? Do you start with a liquid, a solid? What do you start with? A liquid. So you're starting as a liquid, and hopefully it's going to turn into a what? So where on the graph will you start as a liquid and change into a solid? Right here. Okay, now, when it's time to do the test, well, I have another one of those to hand to y'all. So don't lose that. All right, so yesterday. Can you use that on the quiz? No, now I have some quizzes to give y'all, and there will be some of that stuff on quizzes. but I don't actually have another one of those to hand to y'all, so don't lose it.
Pardon interruption. Do you have Jennifer Garcia?
I do.
Could you send it to Ms. Harvey's office for one moment? She'll be right back.
I'll be glad to.
Thank you.
You're welcome. She does not want to see you. Now hush. No, she doesn't. Take the one that doesn't have stripes. All right. So yesterday, okay, we talked about phase changes. Just to refresh for a moment, all right, when we did these, suppose I ask y'all about evaporation. Okay, suppose I ask about evaporation. I would expect at this point for you guys, based on yesterday's lesson, for you to be able to write that as an equation. What does it start as? Okay, so it starts as a liquid. And what does it change into?
Yes.
Changes into a gas. Now, the second thing I would expect you to be able to do is put in the heat. What side does the heat need to go on? This is what we worked on at the end of class. Does it need to be heated up to change into a gas? Or does the heat need to be given off so that it can change into a gas?
And it's deep.
It needs to be heated up. So if it needs to be heated up, it needs to be a reactant. So it would need to go on this side. Okay? So if it needs to be heated up, it has to be a reactant. So does that make it endo or exothermic? Okay, I got an endo over here, or an exo over here. Clearly we disagree. It's endothermic. Okay, so I would expect y'all to know that that's endothermic. Now, I would expect y'all to be able to do that for all 6 phase changes. Okay, all 6. We did all 6 yesterday. Okay, are we okay with that?
I just remember left and right. Is that cool?
I don't care if you remember left and right. Now, I do expect if I say left is a reactant and right is a product, that you're with me on that.
I mean, y'all got that?
Okay.
That's how I remember.
I don't care. If that's what works in your brain to remember it, that's cool. Okay, whatever works for you. Now, if you don't know that and you need help with that, I'm here next week. You need to come get help. Those of you who are absent, it's on the YouTube video. Get notes from your classmates. Watch the video. I don't care how you get your notes, but you need to get them. Okay? Everybody with us on that? All right, so I'm going to get off the phone.
Move up.
Now, we're going to calculate Q today. So, yesterday, we drew this handy little graph, right? Now, these 2 little spots right here. This is Q, and this is Q. The only difference is there are 2 different Qs. But before we do that, we need to review.
What did Q stand for?
That's what we're getting ready to talk about. All right, have we talked about Q before? Oh my God.
No.
We have a benchmark on Tuesday.
What?
And y'all just told me we've not talked about Q before.
Quantum? I don't know. I mean.
It's okay. It's okay.
We really did talk about Q though.
I don't
Let me
remember.
just.
I don't remember.
Okay. Q is heat lost or gained.
Listen, click up like-
Okay? We learned
Is that in June?
Q, yes, equals M CP delta T. Way back in the first week of the semester. Oh, yeah.
I remember.
Okay? And it was in joules, in case you forgot.
What is the title for this?
Heat, if you want a title. Heat will work. It still goes with phase changes, but it's fine. All right. M is fairly universal. It was what? Mass and grams. Okay. You didn't get in trouble, did you?
No.
Thank God. Tired of doing ISS and Jack and Kevin at work. All right. Specific heat. And delta T is change in temperature. Is it coming back to you a little bit?
Yes.
Okay. And specific heat, we found on the reference table. Yeah. Ladies, shut up over there. Or y'all can separate, and one of y'all can go back over here, and one of y'all can move somewhere else. I shouldn't have to ask 3 or 4 times a day. Change in temperature can be in kelvins or degrees Celsius. This is the only equation we used all semester long that could be in either temperature unit. Every other formula we've used had to be in what temperature unit? Kelvins. But this one can be in either. It's sort of unique that way.
Where they gonna be?
Okay? What?
On Tuesday?
Yes.
I
It's
can't
like,
do
it's
that.
like
$28.
Oh, 28.
Why?
That's suspect.
I'm a calculus AP.
That's not my problem. I'm not the one who scheduled the benchmark.
Wait, when is it?
When is it? Supposed to be Tuesday.
No.
I'll make that too.
Nobody just comes Tuesday, all right?
We're not gonna be here Tuesday.
Why not?
Calculus.
Everybody's gonna
I'll
like,
fail that.
I'm gonna fail it. I don't know why I'm going. I'm gonna try, but
You have
I'm gonna fail.
Who knows? Maybe I won't get the test.
it was a nice try.
What are they going to do to me if I don't? Fire me?
Miss Moore?
I doubt it. So what?
You teach me calculus, Miss Moore?
Been a long time.
I need help.
All right. Everybody caught up?
Motherfucker in your brother.
I didn't even say anything.
All right. So
Talk to me.
Shut up.
if we pull up a problem, it's going to be writing with my terrible handwriting. So I'm pretty sure I have these.
I'm gonna pass out.
Please don't pass out. You're not going to bump your head and kill yourself.
It's hot in here today.
Well, let's just be thankful you're warm for a change.
Hold on. All
Right, bro.
right. I'm burning.
Take your hoodie off.
No,
Why? You don't have a shirt on
I
underneath?
do, but
I asked the same question.
I don't want to.
Then stop whining.
Right. Tell him to stop being low.
All right. This would have been a question that we would have
I
done
know you, bro.
way back at the beginning of the semester.
They're not like
Do we need to write it down?
Yes.
All right, write it down.
My neck hurts looking down.
This is fairly traditional.
that.
How many joules of heat are necessary to raise the temperature of 15 grams of water from 35 to 85 degrees Celsius? At the risk of upsetting you, Hyro, what are you doing?
That boy got extra half. He said, oh my God, this wall.
Oh, that's good.
Can I go to somewhere real quick?
No.
Well, kid, when he said that, probably get somewhere.
That is just-
Freaking.
Did you find some ID?
I found that SAT.
There you go. That will probably work.
I got more people.
All right. Now, the first thing that I would point out to you about this question that's going to be different from the 2 questions we're going to learn how to solve today is going to be this right here.
It's gonna be like,
Okay? I'm just pointing this out. The 2 formulas we're going to learn how to use today are not going to have a temperature difference. Okay? I'm just pointing that out. Now, the formula we learned back at the beginning of the semester was finding heat. What does this question ask you to find?
yo,
Of what letter was joules of heat? Q, M, CP, or delta T?
yo,
So we're solving for what?
yo.
Solving for Q. So that means we got to know M, we got to know CP, and we got to know delta T.
Wait.
So Yep.
What is it again?
What is what? Really? What is M?
Yes.
Oh, wait, okay, I know that. So then what's CP then? I don't think.
We're getting ready to talk about that. So what's M?
15.
15 grams. All right. What's delta T?
50.
It's the 85, subtract the 35, which is 50 degrees Celsius. Now, like I said, this is the only one you can do in either Celsius or Kelvin. You can change it to Kelvins if you want and subtract, or you can leave it in Celsius and subtract. It doesn't matter. Now, this is the one that Tevin said, where's this CP at? This is the one that's on the reference table. So you have to look on your orange chart. What did I give you in the question that will be useful for the orange chart? I told you that it is water. I have to tell you what the element or the compound is. So once you know that, you go to your chart. And some of the specific heats are in this table at the bottom. Now, look where I'm pointing at today. See where my fingers are? Right here. See where my fingers are? That's where we're going to be at today. Okay? There's a heat of fusion, a heat of vaporization, and a specific heat of water. That's the table we're going to be in all day today. So see where it says specific heat of water? Water. Specific heat. CP is specific heat. What is the specific heat of water? That's what you're going to use. If it had said ice, you would use the solid, the ice. If it had said steam, we'd use that. But because it said water, you want to use 4.18. So now, all we have left is Q equals M CP delta T. We're looking for Q. M is 15. CP is 4.18. And delta T is 50. So all we need to do is what? Multiply them, and we got this. We can do this with breeze today. So 15 times 4.18 times 50, and we get 3,135 joules. Questions?
There's no significant digits to this. right?
At this point, significant digits are not on the exam. As long as you don't write down every number on that calculator, I am not going to take off for it. If you write down every number on that calculator, yes, I'm still going to take off. Really? How many calculators are you going to pull out of that box? Are they all dead? How many are dead over there?
A few.
How many is a few?
Last time I took it like 3 times to get fencing.
Well, I low key forgot which one we did because I put the cases on it.
It's really hard to go request batteries if y'all keep putting the dead ones back in there and don't tell me they're dead. All right, questions. All right, so let's talk about the new formulas. Okay? So, the new formulas we're going to learn today go with this graph. Whoops, not far enough back. Okay. This graph that we just learned how to read, all right, we could calculate the heat lost or gained to change from a solid to a liquid. All right, so this Q, let me change this graph a little bit. That's a little tiny for me to write here. There, I can work with that a little better. All right, so this Q, all right, this is the heat lost or gained to change from a solid to a liquid. Okay. Now, this is where the state has really trimmed your curriculum. We could do this for any solid to liquid. Those of you who want to focus on a science degree, Destiny said yesterday she was probably going to have to take chemistry because she wants to go into nursing. She's going to have to do this in some college class for any liquid to solid. The state has decided that we're only using water.
Water?
Okay? Which is going to cut down our work tremendously. Okay? We're only going to use water in this class. So those of you who are going to branch out into another science area or going to take chemistry in a college class, I will tell you now, your professor is not going to limit himself to water. Okay? I think it's a disservice to y'all that I'm only limiting us to water, but it's crunch time and that's all the state wants. So that's all we're doing. All right? So this here, this Q is the heat lost or gained to change from a liquid to a gas. And again, we're only using water. So, given that we're limiting ourselves to only using water, these two things are going to take place at particular temperatures in our questions. So this is going to take place at 100 degrees Celsius, and this one is going to take place at 0 degrees Celsius. And that's likely to be stated in the math problem itself. Now, these have names that go with them and formulas. Now, this up here is Q equals MHV. And this one is Q equals MHF. And I'll talk about how those are different on the next board. All right? But they look very, very similar because they are almost identical. But one line is heat of vaporization and one line is heat of fusion.
Oh,
What?
preparation is on the top.
Because it's vaporizing. It's going from a liquid to a solid.
Do we need the right there?
Yes. Now, notice that in these formulas, what variable do you not have that you had in the last one? You don't have a change of temperature. So that's why I said in the word problem that we just worked, you're not going to have a temperature in this question. That's how you'll be able to tell the difference between the last question and this one. There's no temperature in this question. Does everybody have what they need? Can I go to the new board? Okay, Bryce said, hold on.
The H stands.
We're going to talk about it. That's why I need the new board. Got it? All right. So, what do the variables stand for in this equation? All right. Q equals MHF. And Q equals MHV. All right. Q is still heat. M is still mass. HF is heat of fusion. All right. We use this from a solid to a liquid at 0 degrees Celsius. You only use this formula when you change from a solid to a liquid at 0 degrees Celsius. Now, where are you going to find the heat of fusion number? That's right. It's on the reference table. That's right. That's why I pointed it out to you. Now, again, we're only using the heat of fusion for water. You're not going to have to find a different number. Q over here is still heat. M is still mass. HV is heat of vaporization. This time you're changing from a liquid to a gas at 100 degrees Celsius, and it's on the reference table. The formulas are identical, except one is HF, one is HV. The numbers are on the reference table. You just have to figure out which formula to use based on what's in the question. And they're pretty straightforward. They're not hard to use for the most part. All right, is everybody caught up or do you need me to wait? Okay. Are we there? All right, so all right, stupid. Let's do that again. All right, write it down. So we'll talk about how they're different.
Do I have a bathroom pass?
Do you have a bathroom pass? You might. Let me see. Yep, you got one left, that's right.
All right.
You need to use it?
Yes, please.
Take your stripy vest. All right, we're there? All right, so tell me how this question is different from the last one.
It says 0 degrees Celsius.
Okay, it says 0 degrees Celsius. Now, I want you to look at this versus this. Okay, it says freezes. That's one of the key words. All right, first of all, this is a state change. Okay, that's one of the things. But there's an easier thing to look for. It doesn't have a change in temperature. See how this goes from 35 to 85? Okay? Look at that one. What do you see there? You just see 0. There's no temperature change. Okay? So when you look at this, there is no temperature change. All right? Because there's no temperature change, that should eliminate the formula that has delta T in it. All right, so you're either using the HV or the HF? Does everybody see that? Or am I just talking to myself? Yeah?
Sorry to interrupt. Do you have Trenton Reed?
He's not here today.
Okay, thank you.
You're welcome. All right, so Q equals MHV or Q equals MHF. So the question said freezes. So is that vaporizing from a liquid to a gas, or is that a solid to a liquid? Which one happens when you freeze? HF. All right, solid to liquid. So that tells us that's gone. So we're using this formula. So Q is what I'm looking for because it says how many joules? What's the mass? 25.5. And where did I already tell you find HF? On the, so look on your reference table. Where did I tell you to look? That middle block, find heat of fusion. Right there, it's on the first line. What is the heat of fusion? So you write 334, and all you have to do to solve is what? Put it in the calculator, multiply. So 25.5 times 334 is 8,517 joules, and you're what? Done. That's all there is to that question. No, because the grams from here cancel with the grams from there. So you're left with just joules. Okay? Questions? Let's do one more real quick and then you're going to practice. Everybody got what they want? All right, one more real quick and then we're going to practice. All right, so if we look at this one, tell me what you see. Tell me what you know. You know what? All right. You see some what? You see some numbers and letters, so I'm in a little trouble here. All right. What are you asked to find? You're asked to find the joules. All right. What else? All right. I hear evaporation back there from Destiny. All right. So we're evaporating. All right. Do I have a temperature change? No, there's no temperature change. All right. So if there's no temperature change, that tells me I'm not using which formula? I'm not using specific heat. I'm not using that delta T formula. All right. So I'm either using Q equals MHF like we just did, or I'm using Q equals MHV. Since it says evaporates, I'm using HV. All right, so that one's out. Q equals, what's my mass?
35.6.
All right, and where do I get HV?
2,200.
All right, 2,260. And so all I have to do is what? Multiply. So, you look here. Where it says heat of vaporization? 80,000 what? 80,456. Voila. That's it. That's all there is to it.
But we still have another quiz. That'll be on the test on Monday.
Yes.
This is going to be the 3 of them?
There will be the 3 questions, yes, but that will not be the only thing on the quiz, which is why I was trouble. Devin, calculate. 6 questions, find me the answers. Then we're going to talk about equilibrium. Yes, ask away.
Oh, man. It's Friday.
You don't have to memorize anything. There's nobody reference that. The formulas are on the reference table and numbers. Now, if you are formula challenged, all 3 of these formulas are on your reference table. You don't even have to memorize these formulas. All 3 of these Q's are on your reference tables. All the numbers are on your reference tables. You don't even have to know these formulas. You can look them up. All right, find me some answers.
Thank you.
Find me some answers. Yep.
So number two, which is for the 1.0, that was the 4.8.
But how do we know?
Say what now?
Oh, so this is how many calories are given off of the water. It's specifically of water and calories.
Say what now?
I was just saying this is-
Yep.
When it's like
Sorry, teacher.
gas, it's
Oh, you're right.
What are you like?
I'm your mom.
She probably will be.
Thanks, bud. Oh my god.
All right, who's got a question? Yeah. Remember what? Yeah. All it's asking you to do is substitute this in for that.
I don't know what water is. What is CP?
CP's in the same chart.
No, I'm talking about the triangle that does like.
You're gonna subtract. Two temperatures.
No, I'm not saying that.
This wall, I got one that's not working right here.
Do you want to tell me? Where is she? The CP is still 418?
Uh-huh.
Okay.
Mhm.
What are calories?
Just joules. Joules over grams per Celsius is CP.
Well, I'm glad you put on the floor.
What's calories?
What is it?
It says how many drugs are given off.
Oh, specific heat of water and calories.
So,
Okay, what's the again? Would you just put it here? Yeah.
yes, I was thinking about this.
Specific heat of water and calories. Hey, when there's a temperature, you subtract those, right? The specific heat is 4.8.
Miss
I'm
Wong.
not gonna good. All you're doing is taking that and plugging it in for that.
How do we find the calories?
Calories are the same thing, except the number one, take out the 4.18 and put in the calories.
We put 5 times 6, 18.
Perfect.
So the answer, like 250 for the second.
That's something.
Joules?
That's a 50 calories over DC.
No, just
Okay, I think we'll see that.
no negative numbers, it's positive difference.
2, I'm under one.
Oh, you said it's 50.
It says this.
No.
It's 5 times
Miss
15.
Long, come help me.
How many Jews
I need to get
Philadelphia Jews?
Miss Long, I need to come over here.
But that's,
Because I thought this one was this one. Except for-
No, because you got two temperatures, you got a 75 and a 25.
11,690.
Because you got two temperatures, you gotta do what with them? Yes,
I just subtracted that.
yes, and then you want to use this formula because it goes in right there.
Oh, that's a table.
That's why I have a question.
Yeah. How do you do?
Same way as you have one.
No.
Just use the 418, you put the 1 in for the CV. So like right here, instead of putting
How'd you get that?
1. So you're still gonna have 5, you're still gonna have
That's even obvious.
50 there.
What are you talking about?
Number 3.
No, you're.
So
Hey, what's CP?
So we always use that for the equipment, and we always use that for
Hey, how do you know what's in the?
CP is specific.
What's it got right here? 2,000.
How?
So, water will always be liquid. Unless it says ice or steam. then it's
So
not.
I put 4.8 to your added.
Look it up, Buttercup.
Would it be joules?
Hey, if this is for something more important than you gotta be. All right, what's next?
How many joules does it take to melt 35 grams?
All right, so what formula appeals to you?
To melt, so the F one. Would it be that one?
Miss Walker.
Because it goes from solid to liquid.
Got
To raise the temperature.
Which one appeals to you based on what you've read? Condensing. Do you have a change in temperature? Does condensing go from solid to liquid or liquid to a gas? Huh? Which one? You're okay with the formula, your problem is your 2.02. Yes, but no, you're using HD, so you need the HD number, so you need that number. Yes. You need the same thing as you have right here with these numbers, except take that number out and put in. Yeah, so it's the same problem, the same problem here, except change out CP for 1.
How many joules?
It's just that calculating the joules, you're gonna get calories.
Please, is that zero?
Yes, I use these joules, that's what scientific
So is
community
that-
uses. Here in the States, we use calories. Feed is calculated in calories, so when you exercise, you can calculate it in joules like the science community, but we
On the two of
count it
those?
in calories.
Okay.
Question? Good. How about you?
71.75.
Okay.
So. Yeah, 25 grams, and then the change, take it out, and then you multiply by the. So you go on it.
Yep.
To melt, so that's one from. Solid to liquid, so.
Are we done? Need another minute? Where are we at?
What'd you get? For what? Hey, look, wasn't this 3.3 times all, making it right?
No.
What one are you using? The one that HL, so you go. For you?
No, for zero. We put 3.3.
So every time zero, you use the
Every time you, it's HL, it's zero. Every time it's HL.
when it's zero,
When it's HB.
but when it's zero.
Yeah, 0.0. You put one.
Okay.
I think you threw it.
No.
Don't throw it.
I'm gonna throw cheese.
The last one being the one with the
What is it? What do you condense this?
how many
What is it? Steam and it condenses to
grams of water for the
H. HF?
Liquid to gas.
No, that's heat evaporated.
Liquid gas is HB. So that's what it is. 104. Oh, yeah.
You already did.
Oh, should I tell that? No, let her do it.
Mom's doing it.
I got them the homework that we did today.
Are we done?
Yeah.
No.
Yeah.
How many more you got, Salma?
I don't even know what
The
it is.
story behind it is more.
I don't either. I'm gonna hope that to the video.
That was crazy. We were scared.
Yeah.
Right.
Yeah, it was really good. She was like, okay, it's on mute now. What's in the mood for number 5?
I think it was a,
There's no sound.
I think it was
Come
a.
on. I already know because I saw it. The first one, right? Mass times 17. Why do you see it? Yeah, do it yourself.
The one where we talked about Tesla was-
I know, she
What happened?
when me and you she was like going over the text message. She's like, so we put it on mute.
And she was like, okay, it's on mute. And I was like, I'm still here.
She just turned off the volume.
Oh, yeah. There's this one video for you.
You know, it's a really nice place. I think that they are like watching.
Oh, so
And you can read it out.
All right, if you've not finished,
You want
Yeah.
me to write.
sorry, but we need to move on,
Or the.
because I'm pretty sure I have a question for this next topic on the quiz. All right, so the answers. Question number 1 should be 1,045 joules. Question 2, 250 calories. And like I was telling Hema, joules is just the scientific unit that we use, the SI unit, but calories is the English unit, so I typically put something on at least one worksheet because, you know, in the US we use calories. If you go exercise, if you check out food cans, it's all calculated in calories here in the US. We don't calculate anything in joules. We could, we just don't. All right, number 3, 11,690 joules. 4, 192,100 joules. Number 5, 5,225 joules. And 6,
16.
I got 16,700 joules.
That's what he said.
Oh, that's what he said?
Yeah.
Oh, I thought he said 60,000.
what did you get for 4?
4, I got 192,100.
Wait, 1,900.
192,100.
At first I heard 19.
No, 192,100.
0.
Yeah, 192,100. All right, you got it? All right. Now, we're going to finish today with a little bit of a discussion on our next topic. The next topic is equilibrium, and we're going to break that into 2 pieces. We're going to do physical equilibrium first, do a couple other things, and then we're going to do chemical equilibrium in a couple days. All right? It's probably one of the driest topics that I teach. Yeah. It's pretty boring. There ain't no nice way to say it. It's just boring. You probably will. There's nothing I can do for you. I can't make it better. Counting what we'll do on Monday with it, it would be. But fortunately, we're getting out of here in a little less than 15 minutes, so Today won't be long, but if I had to teach it straight through, yes, it's long. All right. Now, unfortunately, this is just part of the curriculum. It will be on the exam. I have trimmed the benchmark to only include those questions that I have taught at this point. Because I took last year's benchmark that Miss George made, and I trimmed out those questions that I haven't taught. So given that no one's going to hold me accountable, just cut out the stuff that I haven't taught. So I'm probably going to count the grade. So looking at equilibrium, what is equilibrium? It is a dynamic condition in which two opposing chemical or physical processes occur at equal rates. Now, there are two important parts in this definition that we're going to focus on in the example the state wants me to teach. Okay, and we could teach this with any examples, okay? But like I said, I'm going to break this into two parts. In the first part, we're going to talk about physical equilibrium, and we're going to do it on Monday. We'll focus on it on Monday. After a couple days of some other topics, then I'm going to come back and teach chemical equilibrium, okay? And that part, for some of you, you'll like the first part because it's math, and the math part's pretty easy. It's the shifting part that a lot of you are not going to like. And the biggest reason is there are rules for whether it shifts left or it shifts right. And what's the problem with the rules? Y'all either will forget them or you won't do what?
Study.
You won't study. It's a lot like the geometries when I told you had to do what?
Study.
You had to study and learn them. Some of you did, and some of you didn't. Some of you didn't show up to do the test because you knew you didn't know much, and you still haven't done what? Still haven't taken the test. Okay? I can't fix that for you. Speaking of makeup work, by the way, next week I have all 3 days I'll be here. The following week, I've got none. Did you hear me say that? I've got none. Don't whine to me when the end of the semester rolls around and we get into exams and I tell you I'm not staying to do makeup work. When I set that last day for makeup work and I tell you I will not take any other grades, I'm done. I've cut them off. And you go, but Miss Wall, I need to get my grade up. And I go, tough noogies. I've been here. I'm not staying. I'm done. It's the end of the year. I'm going home. It's June. I'm putting my feet up. I've worked all year. I'm done. I'm old. I'm fat. I'm going to sit on my couch. Okay? I don't want to hear it. I don't care at the end of the year in June what your issues and problems are. If you have makeup work and you need to get it done and you want that opportunity, I was here all 3 days this week. Destiny can tell you I saw precious few people in here. Okay? I was here a couple days last week. I saw even fewer people last week. I'm telling you, next week I have all 3 days. The following week is a rough week in my world. My daughter does dance. It's tech week. I am at Finch Auditorium all week. The one free day I had for y'all got sucked up by a band concert for my son. Okay? So I've lost every afternoon that I had that week that was free. So I'm giving you fair warning that I've got nothing that week. I mean, I might have 15 or 20 minutes, but that's about all I can give you. So if you've got a test or something you need to make up and you need an hour, it needs to be next week. And I know Hema has one, Salma has one, Brian has one. Don't wait. Don't put it off. Get in here next week.
It's okay. You show me quizzes and stuff.
Go on Power School. I will be glad to show you. If you come next week, I will pull it up at Power School. Do not come during second lunch. Okay? It needs to be when I do not have class if you want me to pull it up. But I will pull it up. All right. So what are my two important pieces here that we're going to have equilibrium in that definition? No, chemical and physical are not it. It will occur either in a physical or chemical process, but that's not it.
Equal rates.
What about opposing? How many?
2.
All right, you have to have two opposing processes. Now, when I say opposing, do y'all know what I mean? Opposing means what? Two opposites, okay? Does everybody know opposing means opposites? I see a couple heads nodding, and some of y'all are just staring at me. Does everybody know that? Okay, so I've got to have two opposite processes. All right, what's the second piece in this definition that I've got to have to get equilibrium? All right, I have to have equal rates. Okay, I just didn't hear you. Now, if I set a piece of ice on my desk, what's going to happen to that piece of ice? It's going to melt. Will it automatically refreeze on my desk? No, it can never get to equilibrium. Okay? So, in order to get to equilibrium, all right, so in order to achieve equilibrium, all right, you must have two opposite processes occurring at equal rates. I cannot say that enough. All right? It doesn't matter if they're physical or if they're chemical. The two we're going to look at, that we're going to talk about over the next day, Monday, are evaporation versus condensation. Now, we could just as easily do this with melting. And what's the opposite of melting? Freezing. I could do it with sublimation. What's the opposite of sublimation? This is why y'all struggle with the quizzes. What's the opposite of sublimation? That D word's not going to float it on the quiz. Deposition. Okay? You've got to know the words. Because if you ask me, Ms. Wall, to spell and count, and I say no, but if all you know is the first letter, am I giving you credit? No, I'm not. Okay? This is why y'all struggle. You've got the math. If I give you 3 math questions, you got that. Woo, you got a 30. But you got to be able to do the other stuff too. This is what's killing y'all in here. You've got a piece of what we did. You got to have the other pieces too. So what's your homework tonight? That's it. I'm not giving you a handout. I'm not giving you a worksheet. I just need you to be able to tell me the 6 phase changes. Know which one's which. Know who's endo and exothermic. Know how to read the graph. Know how to calculate with Q. Know what equilibrium is. What? Do what? No, I did that yesterday.